We are going to go over some questions that are similar to the questions that we covered in the last lesson on calorimetry and problem solving. Some of the assignment may be a little bit different because we haven't gone over this yet, but we will go over that on Monday or Tuesday. Okay, basically, right balance equations, we haven't talked about that yet, but we will go over all that later on. Again, we are talking about calorimetry, so the very basic assumption in calorimetry that we are talking about is an isolated system. So the energy gain of the water is equal to the energy gain or loss from the system. It says substance there, but it should say system. So let's look at a question here. Chemistry experiment, 4.24 grams of lithium chloride is dissolved in 100 milliliters of water. At an initial temperature of 16.3, it becomes 25.1. So, again, just like before, let's break this apart into the chemical reaction and then the calorimeter. So, in the chemical reaction, we have 4.2 grams of lithium chloride. Okay, let's read the question. Determine the molar enthalpy. Okay, so we want to know the energy per mole. So we have mass 4.24 grams, molar mass of lithium chloride. Off the top of my head, I don't know. I see the number, 42.39 grams per mole. And we are looking for the molar enthalpy. Not quite where I want it right now. The molar enthalpy of this reaction per mole. Now the calorimeter, we're dissolving it in water, so that's nice, and we have a temperature change. So we have 100 milliliters of water. So I will turn that 100 milliliters into 100 grams. If you don't, your specific heat capacity will have slightly different units. And for specific heat capacity, 4.19 joules per gram degree Celsius, and our delta T was the difference between 25.1 and 16.3. 8.8 degrees Celsius. So again, what we have here, we have the number of moles right at 0.100 moles. It's that divided by that. So we go ahead and punch everything in to find this. Delta RHM is equal to the calorimeter energy change divided by the number of moles that we are reacting. And again, Marissa, please make sure that you put your units in. Although I did forget one, so you can yell at me when I get that. So what we end up with off my calculator is 36,863 joules per mole. Grams will go away, degrees Celsius will go away. So I'm going to write this as 36.8 kilojoules per mole. So that is, in this case, the heat of ionization. And again, we can add a negative sign to that due to the fact that it is raising the temperature of the water. So it's an exothermic reaction taking place. The surroundings are increasing, so we know it's negative or exothermic, so we'll put a negative sign. Okay, so now this one's a little bit different. An aluminum calorimeter. Okay, 20 grams of nitrogen was burned and oxygen produced nitrogen monoxide. From the following information, determine the molar heat of combustion. Write it. We won't write it as a balanced reaction yet. We're just going to figure out the molar heat of combustion. So there's a couple things that are fairly important here. We are given the mass of the calorimeter, and then we are also given the mass of the water. So that's going to change what's on the calorimeter side. So our system, we have our mass of our nitrogen, which I do believe was 20 grams. And we want to know the delta CHM of this, and the molar mass of nitrogen is 28.02 grams per mole. So number of moles, quick little division there. .7137 moles. Now, where this one changes is on our calorimeter side. We have heat going into the water and heat going into the aluminum cup. Okay, so we're not just assuming that all the heat goes into the water. Some of it is going to go into the aluminum calorimeter also. So we had 500 milliliters of water. Okay. We have, therefore, specific heat capacity would be 4.19 kilojoules. No, I'll leave that in grams. That's the other one. Joules per gram degree Celsius. And then our delta T went from, we started at 72 and went to 12. So we have a loss of 59.8. Now, I'm just going to write our delta T as 59.8 degrees Celsius. In terms of the aluminum calorimeter, we have a mass of 70.37. I'm going to check this, but I believe it's 0.893 joules per gram degree Celsius, and our delta T is going to be the same. Let me grab the data booklet. Not quite, 897. Okay. So in this situation, the energy change of the chemical system is going to the MC delta T, the energy change of the water, plus the energy change of the aluminum calorimeter. So 500 grams times our 4.19 joules per gram degree Celsius times our 59.8 plus 70 point. And that will all be over our 0.7137 moles. Okay, so here it's the exact same thing, except you have to recognize, I told you it's an aluminum calorimeter. If I tell you it's a copper calorimeter, you can figure out this from the data booklet that there is some energy, or that you have the ability to figure out what amount of energy is going into the calorimeter metal itself. Work with our calculators. I gotta write this, so our calculator spits this back out at us, and what are our units? Well, it's going to be moles, because we have this guy on the bottom, grams, degrees Celsius over here, grams, degrees Celsius. So we have joules per mole. Looking back at what I have, I need to reduce that to 3 significant digits. So I will write this as 176 kilojoules per mole. And now the next thing that I will do is this an endothermic or an exothermic reaction? I'm going to use that to communicate. Our initial temperature was higher than our final temperature. So we've removed energy from the water and the calorimeter. So this is going to have a plus sign there to indicate that it's an endothermic reaction. Think about energy being added to the system. That much energy is being added to the system per mole. Okay. In an experiment to determine the accuracy of a calorimeter, the student combusted 3.75 grams of ethane and found the temperature of 1.5 liters of water increased from 15 to 48 degrees Celsius. The accepted enthalpy change or the enthalpy of combustion for ethane is 1,560 kilojoules per mole. What is the experimental specific heat of the water? Okay. So here we want to actually we are given the energy per mole for ethane. We are given delta T, we're given volume, we're given mass of the original solute or of the ethane. So we're going to do again, we go through what we have here. So let's go through. We have the ethane and the calorimeter. In this case, the calorimeter didn't give me any information in terms of, is it an aluminum calorimeter? No, it's just the water. It's just going into the water. So mass, 3.75 grams. Volume over here, 1.50 liters. The combustion of this is 1,560 point something. And molar mass of ethane, 2 carbons, 6 hydrogens, going to be 30.08 grams per mole. We are looking for the experimental specific heat capacity. We know the actual specific heat capacity is 4.19 joules per gram degree Celsius, or 4.19 kilojoules per liter degree Celsius, which is what I'm going to use here. And the delta T is 33 degrees Celsius. So your change in temperature, 33 degrees Celsius. The energy given off by the system goes into the calorimeter, the specific heat capacity here. Again, I like to manipulate before I plug in. A little bit of cheating. I'm going to calculate the molar or the number of moles without writing it down. I know I'm cheating. Again, I'm going to leave out the negative sign here. Let's look what happens with other units. The only thing that crosses off are our moles. And we end up with 3.93 kilojoules per liter degree Celsius. And that is our experimental specific heat capacity. And determine the experimental error of that. Again, experimental error. Is the absolute value of the actual minus the experimental over the actual. And because it's percent, we want that. So our actual 4.19 kilojoules per liter degree Celsius minus the 3.93 kilojoules per liter degree Celsius over. And yes, I do expect you to put in all these units every time. Quick little run to the calculator. We end up with a 6.2% error. So that calorimeter is not perfect, but it's not bad. And I'm going to ask you to complete the calorimetry. There are a couple questions that I'll leave for for the sub, so you don't have to do them yet because we did skip a lesson. And I will see you later.